back? Why is this up here rather than down in the other room?
That would be a good question, and that would be answered at levels above me.
It's because they didn't have room downstairs for what's the room right next to it? There's the.
Anyway, this is kind of the beginning of the system. We've got city feed water comes in. We've got a backflow runner here. We've got a booster pump over here, which will run in case the feed water falls. We've had issues with that on campus, so we've been putting a booster system with a bladder tank and a booster pump in on the front end. That does have a bypass around it if we ever do need to pull that out, work on it, anything like that, we can bypass it if we do need to do that. Applies feed water to, we've got basically a Big Blue 20-inch, it's a dual gradient filter, combination 50 micron and 5 micron, and that's kind of our first, sees everything coming in from the city, particulates, that sort of thing. That one looks like the filter's not too bad right now, and I don't know, and maybe Tony can maybe address, I don't know whether they're going to have service contracts on this.
We generate one for this, do it over Andrew.
Okay. So it probably would be either a quarterly visit or a monthly, depending on how it's written. Looks like
Probably up for quarterly.
looks like they've already changed it out a couple times as it is. That's what these are laying on the floor here. And yeah, more than likely, I mean, if it's quarterly and we're coming up doing a quarterly visit, we'll change it when we do our visit. Other than that, I don't know if you guys are going to be doing rounds and readings and do checks on them. I would probably, when we see a delta of about 10 psi, you start looking, that filter's probably starting to plug up. So once you see that delta, then we need to look at getting that filter swapped out.
About 10 psi?
About 10 psi, and I'm actually thinking.
Looks like right now you're only at about 2.
Yeah, and let me slide back there, Jeff.
Yep.
It looks like that pump is turned off right now. Yeah, you can see how much our pressures were down relatively low. So just firing that pump back on is going to push those pressures up, and that's set. I believe it's factory preset, which is between 40 to 60 at the pump. We're going to lose some as we move through the system, obviously. But we should see that come on and off about 40 psi. Looks like, yeah, we had about 40 psi at our pre-filter here. So when it falls a little bit below 40, it's going to kick back on, ramp it up to 60, and try and keep the pressure within that range. It's really only going to run when either the RO's running or if one of these is in its regen cycle. So the first one we see here is going to be our softener unit. That's for calcium magnesium carbonate. What it is a cation, so it's a negative charged, actually a positive charged resin. I always get the cation. It's been a long time since I took chemistry. But what that does is take out the calcium magnesium carbonate that's in the water. We want to take those out because they will scale up the RO membranes. What happens is they actually deposit on the surface of the membranes, plug the membranes, and we can't get them off. We actually have to use hydrochloric acid and sodium hydroxide to get them off. So we prefer to take it out on the front end. The only maintenance really with the softener is our salt. And we'd like to, right now, it looks like we're a little bit low on salt, and the system's been in use, so, yeah, it's getting pretty low. I like to keep the brine tank 2/3 to 3/4 full. So I don't know if that's something, I know you guys have a lot of softeners across the campus. I don't know if that's something that falls under your umbrella to, make sure that right now, until we get the service contract, that, we keep salt in the brine tank.
This thing was replenished with salt about 3 weeks ago.
Okay.
Something like that. Yeah, it's maybe 3 or 4 weeks ago. So
Okay.
that means it needs to be replenished more frequently than a quarterly visit, right?
Probably, it
So-
might, yeah, I don't know how many,
What we'll do is we'll bring out a certain amount of bags of salt, put it in here,
Okay.
and we'll fill it up and then leave, you know.
yeah, whatever's extra will just be left. But, and that's, you never know how much salt you're gonna use till you get going on it.
Is it based on how much they use?
Yeah.
This one is not. This one is a timer. Right now, we've just got it set up to regenerate once a week. Now, if we have to back that off, I don't know how much water they're really going to use in the lab. Chances are, no one probably has a good feel for that right now. But if it looks like they're just not using a lot of water, the RO's not running a lot, we can back that regen off to every 2 weeks on this particular timer head if we have to. Although this one, yeah, this particular timer head is once a week, so that's the minimum we can regenerate it. So that's what we're doing now. If we do want to back that off, it would be a situation someone would have to actually manually regenerate it. Compared to plugging up membranes and having to put the effort into swap membranes, that sort of thing, salt's pretty inexpensive.
Could do once a week and we can
So-
quarterly visits, we need like 6, 8 bags every visit.
Well, I mean, if they did it 3 weeks ago and they put in looks like they probably put in, 4 bags there, I imagine? So I'd say probably closer to a dozen every quarter. So that I would get.
So you want to keep this about 3/4 of the
About
way full?
2/3 to 3/4. Yeah, that
And
way
you
we
just dump the salt in until the water level rises?
actually just dump the salt in until you get the salt up to about 3/4.
Okay.
Level will stay about there,
Okay.
and the salt will cover it.
Okay.
So so I wouldn't be concerned about. What you can do is, if you want to check your water level, is just pop the top off your riser hood there, look down in there, and you can see. And there's a spider living down in there. Oh, he got in there. Whatever, dude. And this does have a float in it, so it'll only fill up to a certain amount, and that float will stop as well. And what this brine tank is, it's part of the regeneration process for the softener resin. The way that softener resin works is, as the water flows through it, those ions are attracted to the resin because of the charge in them. Eventually, the resin is going to get to the point where it can't accept any more of the ions that are through the water. When that happens, those ions are going to pass through the softener. Well, what we want to do is regenerate the softener with our brine, puts it back into a salt solution. That brine replaces those calcium magnesium carbonate ions on the resin, and they're all flushed over to drain during the regen process. It does a backwash, does a brine through, and then rinses down through it, a fast rinse, and then refills the brine tank as part of its regeneration cycles. And what the brine does is everything goes back into salt state on the resin, and then the resin can begin to accept more ions as the water's passing through it again, and replaces the salt. So we add a little bit of salt. It's, maybe, God, if we have 100 microsiemen coming in, it may boost it up to 105 microsiemen, so it's negligible as far as what we're sending to the RO TDS wise. So the salt will add a little bit back into the water, but once again, the RO deals with it easily. So we want to make sure that we've got soft water to the RO. Membrane's going to last a lot longer that way. Next one is our carbon unit, which is basically a granulated activated carbon. Now, the main function of the carbon unit is for chlorine removal. We want to take the chlorine out of the water because chlorine is such a strong oxidizer. It will actually attack the membranes, and it'll start to eat small holes in them. And what will happen is our quality of water off the RO membrane will drop significantly if we don't take that chlorine out. And that's not reversible. Once those membranes get oxidized, all you can do is put new membranes in. I mean, that's not something you can fix. So we want to make sure that the chlorine comes out of the water as well. This one also will backwash over to drain once a week. What we typically recommend on carbons, depending on the usage, is every 3 to 5 years would be a good probably a good replacement cycle where we would come up, spin the head off the unit, pull the old carbon out, put new carbon in, and then flush it and hydrate it again. So the entire media would be replaced. You know, on this system, doing that is pretty messy. So probably what we would do is, you know, in 3 years or so, when we start looking at that, we'd probably come in, figure out a way to cut a bypass in, and put an exchange carbon tank in here, pull this out, take it back to our shop, and rebed it there, and then bring it back up. You just throw an exchange carbon in, so you know we don't have to shut the system down, because it's pretty messy, and probably wouldn't want to try and do that on site here with classrooms and you know, students and that sort of thing. When we go ahead and do that, I mean, especially this one's small enough to where it's pretty easy to get in and out of here, get it down the elevator. So with these units, you know, there's not a lot of maintenance, like I say, on the softener. Brine, just make sure we put salt in the brine tank, and the fact that you continually use salt is a good sign. That way you know that it's regenerating, the head's working properly. You know, if a time would ever come where all of a sudden you would stop using salt, then that would be a time to do some further investigation, because something's not, either it's not regenerating properly, the head's not working, it got unplugged maybe. You know, something's plugged in the head, it's not working properly if it stops using the salt. So that's kind of the first line of diagnostic on the softener is, am I still using salt? And you should use it with regenerating once a week. You should use it on it should be pretty regular. You know, you shouldn't see major fluctuations in your salt usage. So from the carbon unit, we go into our RO unit. So once again, we've got a pre-filter on the RO unit. You know, its main function is as the carbon is actually taking the chlorine out, it tends to give off fine carbon particulates. So we want to take those out before they get to the membranes. And anything that gets past the first pre-filter, you know, very, very fine particulates, that sort of thing. This is a 1 micron filter, so we'll catch those particulates in this filter. And once again, delta P of about 10 psi. Otherwise, we would do that on our visit, you know, our quarterly visit. From the RO, basically we've got reverse osmosis membranes. The theory behind those is, you know, with an osmotic membrane, basically everything balances on both sides of the membranes. Your pressures, your water quality, that sort of thing, because they migrate through the membranes, everything balances. With reverse osmosis, we use a high pressure pump, and we actually create pressure on one side of the membranes, push the water through the membranes, and the water that goes through the other side of the membranes, the things that are ionized, that are dissolved in water, will deposit on the surface of those membranes. So the water on the back side of that is going to be pure. That's going to be our high purity water, and that will be our product water. We also will have, I don't know if you guys noticed while this was running, we had some water coming over to drain here. While the RO runs, we always do have a reject stream, and we want that to run over to the drain. Does a couple things, carries the contaminants that the membranes take out, takes those to drains, keeps some velocity across the surface of the membranes too, helps keep them scrubbed out. So we always want to be able to take those away, so we always want some water going over to drain. You know, typically we'll run them about 65% recovery, which means that say if we're using 100 gallons a minute of water in an example, we'll be making 65 gallons a minute product water and 35 gallons a minute to drain. So we're using 65% of our water usage is going to be for product. And that will be a fairly typical recovery that we like to run the RO. So you can run them harder. The harder you run them, the more quickly you're going to plug up the membranes. You know, and unless you're in a situation where you absolutely have to have that product, you know, just run them at a little lighter recovery, and you'll get more life out of your membranes. You know, membranes like these, 4 inchers, you know, you can set them up to clean them, to clean in place, bring a cleaning skid up. Typically we don't do that. Economically, it usually works out better to just replace the membranes rather than to pay for all the labor to have somebody come in and spend the whole day cleaning membranes. You know, a unit like this, it would take us an hour or so to replace both those membranes. So the economics are such that you're better off just replacing the membranes. You know, we've got systems out there that are big, have a lot of big 8-inch membranes, which are expensive, have 20 or 30 of them. Those are more economical to clean.
It's a dumb question. Where are the membranes?
Membranes are right around here.
Those white tubes.
Yeah.
Right, we've got our vessels right here. What the membrane looks like, if you cut one in half, looks like a roll of paper towel. It's just a big sheet of semi-permeable membrane wrapped around a central core. And that central core has holes punched in it. So what we do is we use this pump to create pressure on the outside of that membrane, push the water through, the water comes out the middle of the core. So basically the center of these membranes, that's going to be our product. The side ports are where we're feeding the membranes. And something like a unit like this will use the pump to feed the first membranes. The reject water from this membrane will feed this membrane. So we'll feed them in a series. And depending on the number of, this one is just a 1-to-1 because it's a small RL. You know, you can do 5 to 4 to 3. I mean, there's a multitude of configuration you can use depending on the amount of membranes that you have. This one's just a 1-to-1, so the reject from the first one. So the water feeding the second membrane is actually going to be a higher TDS than what the city's sending us, because we're going to be concentrating those ions and the things that we're taking out of the water in that reject stream. If the RO is running properly, your reject stream typically will be 3 to 4 times higher than what your feed water is. So the product water coming out of this one isn't going to be quite as good as the first one, but it's going to be very close. We're still going to get typically a 95 to 99% rejection rate. So of what's ionized and dissolved in the water, we're going to be taking between 95 and 99% of that material out of the water. So we want to see that. And that is a display that shows up. Right now we got tank full. That will show up on a monitor here. Industry standard, when it starts getting down close to about 90%, we start looking at, okay, the membranes are starting to go. So we need to start looking at, whether it's replacing the membranes, cleaning the membranes, whatever we have to do to bring them back, up to snuff. Yes, I'm trying to think. Turn this thing on a little bit. There it is. So we'll turn it on in direct feed for just a little bit of time, just so you guys can see it run. So basically we've got an inlet solenoid valve, opens up, sends feed water through our pre-filter into the suction side of the pump. We also bring a certain amount of what we call reject recirculation. A certain amount of that reject we bring back through to the front of the system. Does a couple things for us. Helps with water conservation. We don't waste quite as much water. Plus it can be of use in helping us to kind of balance the system as well, pressures and flows, that sort of thing. Once you get them turned on, we've got you can see the delay counting down. So we've always got it because we want to kind of flush the system out before we turn that pump on. So there's the pump turned on. So you're seeing right now we're sending about 2 gallons a minute to drain. We can adjust these a little bit. Pressure-wise to membrane, about 150. So now these are this pump is significantly oversized. These are configured to be modular. So if we ever decided we needed to, we could add more membranes to this particular skid. We've got basically a pump control valve here. So we're going to have, you can see we've got about a little over 220 or so PSI on this side of the valve. That's what the pump discharge is. We're actually sending about 150 PSI to the membranes, and that's about where we want it. And what will happen is as the membranes plug up over time, as we see that, our pressures will come up and our flows will come down, just like a pressure, just like a filter. We'll start putting more and more back pressure on the system. So that's something to look at is, are my pressures going up, my flows are coming down. it could be one of two things. It could be the membranes are plugging up. Also, right now we're putting about 15 degrees C to this. The colder the water is, the harder it is to push that water through the membranes because cold water is denser than warm water. So you're going to see, you can see some increase in pressures and some decrease in flows based on your water temperature too. Now one thing with, since it sounds like we're going to be doing a quarter, we also have a laptop program. The guys will come up and take all of our readings, will baseline everything. When we put all of the data into that program automatically compensates for that temperature. So it'll do the calculations and say, okay, say the temperature is 6 degrees instead of 15 degrees, it'll compensate for that, and it'll spit out what we call a normalization and also a fouling factor. And if those are within the parameters that we want, we're still all right, even though our flows and pressures may have changed. It's just caused by the temperature. And if it isn't caused by the temperature, then we'll start to wander outside of those parameters, and we'll see that in that program. And we'll know that the membranes really are plugging up, as opposed to it's just because we've got temperature fluctuation. Now you guys are probably pretty lucky here where our feed water is. It's probably going to stay fairly consistent. I've got places where the feed water, the RO system is right next to an outside wall, and that's where the feed water comes in. I've seen it as low as 5 and 6 degrees C feed water for the RO. That doesn't hurt the RO. The RO is not going to make as much water. It's probably going to make a little better water, but it's not going to make as much. We do have a high temperature alarm in here. We don't want to send any more than 35 degrees C to the membranes because it'll actually start to damage the membranes. So we do have a high temp alarm in here. Typically, the alarm you're going to see on this is more than likely low feed pressure.
What would ever cause the supply water temperature to get hot?
We do have places, some places you can temper the water if you want it to remain really consistent. You try and keep between 20 and 25 degrees C. That is kind of the industry standard for a good balance point between flows, pressures, and quality. There are places where they have to maintain a certain amount of product water coming out of their RO, so they'll temper the water. Once in a while we'll have a tempering valve there. The cold side will go out, and we've got one that University of Wyoming, Tony's been in that room, the damn room is 105, 110 degrees because it's got boilers and everything, and literally they're not tempering the water until they actually went in there and did some venting. We couldn't keep the water temperature below 45 C. You would go through, you'd put your hands on the softener and it would be warm. And we'd have problems and fittings all leaked because you got plastic going into brass. They had all kinds of problems just because where the system was in that hot room. We had to deal with it. Finally got it dealt with. I had to actually put the temperature alarm up higher because the RO wouldn't run until we got enough water flushed through it to where it would actually cool down a little bit. So there are occasions where we'll have a high temperature alarm. It's rare, but we still want that alarm. Like I say, typically what you're going to see on this is probably a low feed pressure alarm. Somebody turns the valve off, the pump doesn't come on. These are interlocked through the RO, so while these are in the regeneration mode, the RO won't run. You'll see a pre-treatment out or a pre-treatment interlock sign on here, so they come and say, hey, my tank's lower than where my level sensor, but the RO's not running. You come up and look at that. If you see pre-treatment, you just have to wait for the pre-treatment to come out of its regeneration. And once in a while, we had one a couple weeks ago that got stuck and the piston got stuck and it wouldn't come out of regen. So if you come back an hour and a half or so later, it's still not out of regen, then something's going on.
What is the typical regen?
The softener is going to run an hour and a half.
Okay.
The carbon's about 40 minutes. Yeah. So if you come in and you see it's in pre-treatment, it shouldn't be any longer than an hour and a half. That it will come out of pre-treatment. So if it goes longer than that and hasn't come out yet, we need to do some more investigation for something else that's going on.
This is set up on a time clock, right?
Yep, these are both set up on time clocks. So they're going to regenerate. They come factory preset from manufacturer to regenerate at 2 o'clock in the morning. We typically leave it factory preset. 99% of the time nobody's going to be using water at 2 o'clock in the morning. So we go ahead and regen those so we don't interrupt service. There are some places where they want to actually be on site while it's regenerating, so we'll shift. There are places where they run 24/7. We'll shift it around depending on when their slow time is during their day. But for the most part, these will go ahead and regenerate at 2 o'clock.
If the power were to go out overnight, say there was like a blackout or something, will these systems reset themselves and turn themselves back on?
They will, yeah. What will happen is turn it back to tank mode. So basically you can choose whether you want just it to run or whether you want to run it in tank mode. What I did is I put it in direct feed so it's not paying any attention to our set points in the tank downstairs, just so we can see it running. Just got to remember to turn it back or it's just going to keep running. It's not going to shut down no matter what the tank does.
Okay.
So yeah, in the menu, I mean, we've got all of our, you probably shouldn't have to get into the menu. It is in all the O&Ms to get in here. We've got all of our alarms, startups, things like that. We have delays built in. We've got our alarm set points set in here. We also have delays bit in, so that it's, we're not getting a lot of nuisance alarms on it. You got a quality alarm. You want to let the thing run for 60 seconds or so before you actually trigger the alarm. Same with like a high temperature, low pressure. The good thing on the low pressure alarm is it will try and restart itself 5 times if it's just an intermittent blip. If it's not, if after 5 times, then yeah, someone will have to come and manually reset it. But at that point, there's probably something else going on too. Either you've got a filter that's completely plugged up, there's a valve shut off, something. So we want the unit to kind of prompt us to, hey, let's look at a little further at what's going on. But if we just get little blips here and there, which happens in buildings once in a while, especially a blue building once in a while, the 5 times will compensate. It'll start. I think right now I've got a minute set in between restarts, so it'll wait a minute, then it'll try and restart, then it'll wait a minute. So it'll, hopefully compensate for those little bits of ups and downs here and there. And yeah, the tank's full downstairs, so she won't try and run.
So just a minute ago, you were kind of giving us, tracing the path of the water, and you got up to the pump. Can you
Sure, yeah, absolutely. So we come from the discharge of the pump, we come up, here's where we feed our first membrane.
Okay.
Now on the bottom, we've got, you can see that blue hose on the bottom there? That's the reject from this first membrane vessel. That's going to feed the second vessel.
Okay.
Yep. Second vessel comes out, we've got our reject flow coming here, and ties into here, and then this is where we control. This valve controls the reject going over to drain. This valve controls how much water we send. You can see the pipe comes through, dumps back into the suction side of the pump there.
Yeah.
So that's where we control how much water we want to bring back into the front of the unit. And we'll use that as kind of a balancing to, we'll set up our product and our reject based on what we want our recovery to be, and then we'll use the reject recirculation to maintain our pressure about where we want it to be. Now these membranes are low energy membranes, so we want to keep the pressure at 150 psi or below that. I mean, they'll tolerate higher pressure. I mean, we could run them up to 250 if we wanted to. No reason to. We're not going to gain a whole lot by running a lot of pressure, and then we'll be able to use that as a diagnostic and troubleshooting tool. When it starts to creep up above that 150, we know, okay, the temperature's really falling or our membranes are starting to plug up. So we look at that. That kind of another data point that kind of spurs us to, let's look at things a little further. rather than just come in and say, yep, it's flowing, it's on, walk away. And most people are like that. As long as it's running, they won't really look at it any further. But if you have a little bit better idea to look for, sometimes you can kind of use it as a predictive and say, okay, rather than wait till it fails completely, say, okay, the next 2 months, let's get together and let's look at throwing some membranes in or changing filters, so that sort of thing.
So the changing of those pre-filters, is that going to be on the FACMAN side of things, or is that something you guys can also do?
We'll do that as a part of our quarterly visit, and that may be sufficient. It's a good possibility. It's actually the incoming feed water right now is pretty good. It was 110 microsiemens. So right now the city's sending you good water. And I don't know on I know they do. The city of Boulder is notorious for changing their feed water sources. They'll either pull from Batasso, Boulder Reservoir, or Carter. Carter and Batasso are both pretty good. Boulder Reservoir is crap. And we won't notice till we get a bunch of customers calling and say, hey, my tanks aren't lasting long. And we'll know, okay, the city probably changed. And it basically your TDS will actually triple. It'll go from about 110, 120 up to about 350, 370.
What's
and
TDS stand for?
Total dissolved solids.
Okay.
So yeah, that's
what's
right. What's dissolved? Yeah, exactly.
Okay.
What's dissolved in the water? Yep. Like I say, right now it's about 110. So they're either pulling from Batasso or Boulder, probably Batasso for you guys, I would imagine. But yeah, we'll see that go up to 350, 375. I've seen it as high as 550, 600 coming out of Boulder in the springtime when we got a lot of runoff. And yeah, that'll kind of play a hell of stuff.
Kind of a good rule of thumb too on the pre-filters, if you guys do your rounds in here, just a quick glance at the filter pressure across the filters.
Yeah, just
if
that
it's
delta.
10 psi or better, change them.
Okay.
Save you some emergency calls.
Yeah,
All right.
if it's starting to creep up.
It'd be a good idea maybe to get a case of the 5 microns, case of the ones. You guys probably have these in several different locations.
Yeah, I'm sure they've.
Okay.
I know they've got some of the dual gradients in a lot of the locations. Same with the big blue microns. Some of the other systems use the smaller 20 and 10-inch 1 microns. But yeah, a few spare filters wouldn't.
Yeah.
These ones coming straight out of these?
Yeah, coming straight into and straight out. So this one, we've got basically a gauge here and a gauge here. So we don't have a gauge real close. So we're gonna, this one is gonna be a little bit. You're probably gonna get a little bit higher delta, just because we're gonna get some friction loss through the, through the piping. So this one delta probably maybe use more as maybe 12 psi, just because the front gauge is a little further away than. We would like it right here at the filter housing, but it's just not on this one.
So look at
yeah,
this one, if it's dropping below 12, then it's
This one,
kind
if we've got the delta across, yeah. See, this one's running 50 psi, this one's running 30 psi.
Okay.
That gives us the delta of 20 across it, and yeah, 20 psi, that filter is definitely plugged.
Okay.
For sure. But we've probably got a little bit wider range we can look at, just because they're stretched out further apart.
Okay.
Pretty inexpensive filters. I mean, if you have to change them, if you pick a number and say, hey, if you see a delta at this,
Okay.
I mean, I don't, a couple pounds ain't gonna matter, but
Yeah. You look at this one, we got.
Excuse me.
all right, let me get an item so you guys.
This will be our distribution system. So the RO feeds the storage tank coming from upstairs right down here. Yeah. Now what I do, we've got proximity sensors on the sides here. These are just infrared. They'll be sending infrared signals, so you signal back. They'll actually read the level of water. We've got 3 of them. We've got RO stop, RO start, and then this is going to be our low level shutdown for the distribution. So if the tank ever does get down low for whatever reason, obviously the RO is running right upstairs, that sort of thing. We'll shut this pump off so we don't sit there and run it dry and run it wet. So yeah, to get the RO running upstairs is just use the tank drain valve, just draining up water. Drain it down to where our red lights will go out. The green is power lights, the red is whether it's sensing water or not. So we'll just drain it down below the middle one, and that'll just let me know. Level controls are working, everything's working upstairs. I don't run the risk of doing something stupid or getting something. So from our storage tank, we're going to come around the backside into our skid right here. So this will be the suction for the pump. So we're coming out of the pump, up from the pump to our deionized water tanks over here. So you can see we've got our hoses that feed the tanks tied in over here. Hoses go back through. Now these tanks are running parallel, so we're splitting up product stream, feeding the two tanks, and then back out and back together. So they're not in series, they're parallel configuration. We did that for flow. You get a higher flow rate that way. Okay? Come back from the tanks. Here's where we come back from the tanks into our system again. Through our UV light. The UV light is, we've got 2 UV bulbs in there. Ultraviolet light, that's for bacteria control. We use that ultraviolet light, 254 nanometer intensity to kill bacteria. Out of the UV, we're going to come through these are our 0.2 absolute filters. So what they do is, the bacteria, the little bodies, any remains, any live bacteria that may make it past the UV. UV does about 98%, something in that range of kill rate, but they don't kill everything. We'll take those out here, and then we'll go from our filters out to all the points of use in our loop. So we're going to cover everything, I believe. And I'm not even sure Jeff would probably be able to tell us better whether this is 1-4 or 2-4. 2. So it is. Yep. So it does go up 7.6. I thought that might be the case. I couldn't remember what the number was. Yeah. It's been a while since I've seen it. So yeah, we're basically going to cover, going to travel through all of our points of use in a big loop. Come back from our loop. We've got a back pressure regulator here, which basically is just it's a spring that holds against the diaphragm, and that spring will hold that diaphragm at a certain level. As they start to use water out in the loop, that diaphragm will close down, so we hold a specific pressure out on the loop, so that, if you got a bunch of people using it, the people at the end of the loop aren't going to starve for water because there's a bunch of people up front are using it. And then when everybody stops using it, that spring will come back out. So we're trying to maintain a pretty consistent pressure on the loop. Now, if you do start to see people start to say, hey, I'm not getting enough water, that sort of thing, we can adjust that spring and change the pressure that we're actually holding on the loop. We shouldn't have to, but sometimes you get people who are, you get a big user on the front of the loop, starves everybody in the back end. You got to crank that down a little bit to make sure that everybody maintains a consistent pressure. Some people complain that they've got too much water pressure coming out of the goose tank, that sort of thing. We can use that. I know all the goose tanks have isolation valves, so we could probably adjust some valves down under the sink as well if we had to. But that's a nice easy way to change the spring. We've got a loop drain right here. If we ever do come in and say we've got some bacteria contamination, we want to sanitize the system, we'll use this to drain the loop, close that off without sending the sanitizer back into the storage tank. That'll help us sanitize and rinse the system up a lot quicker. And we can also do that if we just want to rinse the loop out and not send the water back into the storage tank. Open that up, close that up, we'll just push loop water to drain. We'll have to keep an eye on it and have to keep the RO.
It's a good valve turn too if you want to drain that tank down.
Yeah, you can do that too. You open that up and use that to drain the tank down as well. But yeah, this is just from the loop. It goes right over the drain. This end of the system actually is pretty simple. It's just a pump, feeds our loop, comes back. DI tanks, we've got our quality reading here. Now we've got A is our quality going out to the loop. B is is our quality coming back from the loop. So we've got two sensors. We've got a sensor right here that measures the water immediately as it leaves the skid. We've also got a sensor up there that measures the water coming back to the loop. Now, we will typically see a bit of difference between the two. The nature of DI water, once it stops being polished, it starts to degrade in quality. We're actually doing real well here. We're holding 17.1 going out, 16.3 coming back. So we're not losing a lot of quality in that loop. So that's really good. I mean, you can take a beaker DI water, pour it in at 18 megohm, put a probe in it, and it'll go down to 1 megohm within a couple minutes. Just because it's absorbing ions from the air. Because DI water is fairly aggressive. Water is universal solvent. That's why they call it that. And DI water is even more aggressive. So it'll dissolve a lot of things. That's why you have to use plastic, stainless steel, something like that, where you're not drawing a lot of ions out of the water, out of whatever material you're using.
Another fun question. So equipment upstairs produces RO water.
Yeah.
This equipment produces DI, or as in addition to the RO, now then it's DI now.
Right. Yeah.
So I know in some labs they have just a faucet for DI water. So can you have DI water that's not RO water?
Oh yeah. Yeah.
Okay.
Yeah.
Those are not nuclear.
Right, yeah, you can just use, in fact, we've got a lot of the systems, I know the Ramblings like that. A lot of the small under sink system will have a carbon, probably a couple of DI tanks under the system. Carbon's taking chlorine out, and then our DI is done a worker polisher, so the first one takes most of the load, and then the second one polishes up to a real high quality. When we do our extremes, we'll have what we call a QC light, quality control light between the two that's set. It can be set 200K, 1 meg, 10 meg, wherever we want to monitor that. When that goes from green to red, the guys will come in, they'll pull the worker out, they'll take the polisher, since he's haven't seen a big load, put that in the worker slot, put a new tank in the polisher slot. So we do a rotation, and economically works out a little bit better. You get the most life out of your tanks that way. But yeah, you can, absolutely, you got carbon, you want to filter, and then you have a couple of DIs in order to create DI water.
The water they have coming out of their lab is RO and DI.
Right.
So it's DI quality.
Everybody has the same faucet on this one, yeah.
This gives just distributing it and polishing it. So everything that's circulating through this facility right here is DI quality.
And when you say polishers, that's what we're doing here.
Right, we're polishing that water.
Yeah,
Yeah, we're taking that, 1, 2, 3 microsemen water, pushing it up to DI quality, which conductivity is 0.06, 0.05 microsemen water. We use conductivity instead of resistivity. So we're polishing that to a really high level.
On your final filters down here, what's your pressure differential across these before they need change? Is
Once
that
again, we
about
should
10
look
as
at
well?
about 10 psi. Yeah, right in there. Right now, looks like we're not running much. Looks like we're only running about 1 or 2 delta there. Now, we'll change those probably either every 6 months or every year, depending on how the contract's written, what the end users really want.
I'll probably write it up for annually. Initially, if there's, you guys notice an increase in delta, then we can always change it. But initially, these things don't typically increase a whole lot. So, unless you get some breakthrough in the beans or something happens that causes that, I'll typically start it off with year change-outs. And then we'll do those filters annually, we'll do the vent filter annually.
Yep,
Typically.
we've got a vent filter on the storage tank. It's an atmospheric tank, it's not a pressure tank, so we don't want to either pull a vacuum on it or put it under pressure. So as the water's going down, we're going to go out there into the tank, and water come up, pushing air out. So we do want to filter that water. So we've actually got a 0.2 filter as well on the tank. That way we're actually, any bacteria or anything, we're actually filtering those so they won't get drawn into the storage tank. So that helps keep it high purity. The one thing that really will help keep these filters lasting longer is the RO does a good job with bacteria these up is if we get a lot of organic bacteria activity, they'll plug up quicker. So say if we had just a straight SDI system that didn't have RO in front of it, we would probably change these up more often. We're not going to get quite as good, bacteria and organic removal as we will through the RO. With the RO, and that will help these things. We'll change these things at 6 months as well, and they should last a good 6 months. This will be a good, if this starts to crack all of a sudden really quick, then we may have to change them out more often. I really would doubt that that's going to happen, based on the fact that we got RO, DI. It's all for the most part lab usage, so our usage isn't going to be exceptionally high on this system. We're not going to be putting very low on it. UV lamps, they'll be yearly as well. Octafine recommends 8,000 hours, which is real close to a year. And we do have I've got a temperature alarm in here, 35 degrees C as well. You'll see that go up and down. Right now they're probably not getting a lot of use, so our temperature will climb a little bit, maybe up in the mid-20s. They start using a lot more water, that temperature will come down. We'll send a little cooler water from upstairs. We'll be turning this tank over a little more often. We don't have, the pump's going to add some heat to it. UV lamps are going to add some heat to it, just the fact that it's recirculating in the loop, not getting turned over. So it wouldn't surprise me to see those run 24, 26 degrees C. They start using a lot of water. I could see those drop down to 17, 18. So that would be a positive concern about it. That's going to be normal.
Water dripping out of there. You can see it coming down the side.
Yeah, and I've actually got we got a leak over here.